Hi everyone, welcome back to my channel Pharmagist. Myself Dr. Haimavati. In today's topic we'll see about the drugs acting on central nervous system. This is the second part of the video on the topic sedatives and hypnotics. So these sedatives and hypnotics are the drugs which act on the central nervous system. In the previous video I have discussed about barbiturates. In the present video I'll be discussing about benzodiazepines. So let's begin our video. So, what are sedatives and hypnotics? They are non-selective or general depressants of the central nervous system. So, they depress the central nervous system. So, this is used in conditions where it is required to induce sleep or sedation. For example, in diseases like insomnia, so where the patient is unable to sleep, we use these drugs, sedatives and hypnotics. And also we use these drugs in withdrawal symptoms. So people who are addicted to drugs and alcohol, when they suddenly stop those drugs, so in the rehabilitation therapy, these sedatives and hypnotics are used. So in that withdrawal symptoms, the patient undergoes a lot of anxiety problems and he is unable to sleep and he is overexcited. So in such conditions, this sedation-like state is required. Hence, these drugs are used as uh, tranquilizers or anxiolytics in anxiety patients. And these sedatives and hypnotics, they are classified into three classes: barbiturates, benzodiazepines, and miscellaneous drugs. So all the non-barbiturate drugs and non-benzodiazepines, they come under the miscellaneous drugs. The benzodiazepines, they are widely used as anxiolytics and sedatives and hypnotics. So these are the preferred or the safest choice of drugs for these conditions because they have lesser side effects and lesser tolerance when compared to the barbiturates or the miscellaneous classes of drugs. We will see in the next slide about what are the differences in their effects. Now first let us study the structure-activity relationship of benzodiazepines. So the benzodiazepine contains three ring structures: A, B and C. So as you can see here, it contains three ring structures. The A and C are benzene rings, whereas the B is a diazepine ring. In this diazepine ring, you can see it is a 7-membered ring which is having 2 nitrogen atoms. So in this benzodiazepine structure, the positions 1, 2, 3, 5 and 7 are very important for its activity. So in this position 3, if you replace it with a OH group or the hydroxyl group, it decreases activity. Okay. So and next, if you introduce a carboxylic acid group, that is a COOH group over here, it increases the duration of action. Okay. So in this benzodiazepine ring at position 3, if you are substituting it with OH group, it reduces the potency of the benzodiazepine. Whereas if you introduce a carboxylic acid COOH group, it increases the duration of action. So it is not having any effect on the potency, but increases the duration of action. And at position 5, introduction of any ring-like structure like this phenyl ring or any alpha pyridyl structure or any cyclic alkyl group. Any such cyclic groups, they increase the activity or increase the potency of these benzodiazepine drugs. And then position 7. So this position 7 is also very important for the activity of benzodiazepines. So at this position 7, if you are introducing any electron withdrawing groups like halogens, chlorine, bromine or else nitro groups, they increase the potency of these benzodiazepines. And then the double bond which is present at this 4 and 5 positions. If you are removing this double bond or if you are saturating this structure, what happens? That also reduces the potency of these benzodiazepines. And even if you shift this double bond to these positions 3 and 4, then also it reduces the potency of the benzodiazepines. Okay. And then if you are at this 1 and 2 position, if you are introducing any triazole group. For example, like this. So this is the at 1 and 2 position. You are introducing a 5-membered ring structure. It increases the activity of this benzodiazepine. So if you introduce a triazole group, it becomes alprazolam. So alprazolam is also a very potent benzodiazepine drug. So here for the activity of this benzodiazepines, position 1 and 2 and then position 3, 5 and 7 are very important for its activity. Next, the different drugs which are used in as sedatives and hypnotics under the benzodiazepine classification are diazepam, oxazepam, clorazepate, lorazepam and alprazolam. So here when you can see, so here as you can see this diazepam and oxazepam. Actually oxazepam is a metabolite of diazepam. So diazepam metabolizes to form oxazepam, which is also having sedative and hypnotic activity. So we can say this diazepam is a proactive drug for oxazepam. And then we have clorazepate, lorazepam and alprazolam. Next, another drug in the benzodiazepines is zolpidem. So this zolpidem also comes under this benzodiazepine ring, but the specialty over here is it does not have the diazepine ring. So as you can see here in this structure, it is not having the diazepine structure, but still it comes under the classification of benzodiazepines because of its mechanism of action. So this zolpidem, it binds at the same receptor site where these benzodiazepines bind. So that is why it is given under this classification of benzodiazepines. Now coming to the mechanism of action of benzodiazepines. So the mechanism of action of benzodiazepines is somewhat similar to barbiturates as we have seen in the previous video. The only difference is here on the GABA receptor site there is another site for the benzodiazepine receptors, as you can see here. So there is another receptor site for these benzodiazepines to bind. This is known as the benzodiazepine receptor site. So here what is happening is initially the GABA should be bound to the GABA A receptor over here. So in the case of benzodiazepines, GABA should be bound to the GABA A receptor. Then only these benzodiazepines they can come and bind to these benzodiazepine receptors and produce their activity. As a result, what happens? The chloride ion channel will open and the chloride ions will enter into the cell. So this is how the benzodiazepines show their action. So here what happens is the GABA should be bound to GABA A receptor. Then only these drugs they can bind to the benzoreceptor site and as a result the chloride channels will be opened and chloride ions will enter into the cell. Whereas in barbiturates, the barbiturates they simply bind to the GABA and increase its action. But here GABA should be bound to GABA A. So that is the only required condition in case of benzodiazepines. Now let us see the other class of drugs. So the non-benzodiazepines and non-barbiturates. So they come under the miscellaneous classification. So here first we have the amides and imides. Under this we have glutathione. So this is the structure of glutathione. And then we have alcohol and their carbamate derivatives. Under this we have the meprobamate and ethchlorvinol. So they are analogues of alcohol and carbamate structure. Next we have aldehyde and their derivatives. So in this we have triclophosodium and paraldehyde. So here these drugs they have nowadays become obsolete. That means these miscellaneous classes of drugs they are not used as sedatives and hypnotics. Previously, long time back they were in use, but now they are withdrawn from the treatment as sedatives and hypnotics because of the introduction of more safer drugs like benzodiazepines. The problem with these drugs is they also cause addiction. So they induce sleep, but what happens is the patient gets addicted to these drugs apart from the those withdrawal symptoms. So as a result what happens? tolerance to these drugs and further addiction to these drugs happens. So that is why these drugs, they have been withdrawn, and they have more serious side effects also. So that is why benzodiazepines, they have lesser side effects. So they do not have the addiction property. That means even if they are given in higher doses, the patient does not get addicted to these benzodiazepines, and so they are more safer to use when compared to these miscellaneous drugs and also the barbiturates. So barbiturates and these miscellaneous drugs, they have the property of causing addiction. Okay, so because they are already given for the withdrawal symptoms. So what happens? The patient gets more addicted because they are increasing the sedation and the hypnosis. So the patient feels more happy. So that is why they cannot come out of those doses. So hence what we do? We have to give a drug which does not cause this addiction. So benzodiazepines, they do not have the addiction properties, and they have lesser side effects when compared to these drugs. So this is about the different drugs which are used as sedatives and hypnotics, which act on the central nervous system. I hope the video was informative. So if you have any further doubts, you can ask in the comment section. So do not forget to like and subscribe to my channel. See you in the next one.